Okay. Good afternoon. Welcome back from lunch. I hope everybody had a chance to network and make some new connections and look at some amazing posters. My name is Carrie Freak, and I'm really happy to be facilitating this afternoon's panel. I work at XPB Water Partners right now, but I've been in water and water innovation and water and community and water and media for a very, very long time, it feels like at this point. And I'm a former UW alum. So it's really nice to be back here, and I don't think I actually stepped foot in Fed Hall while I was here, but here I am. There are no drinks. So let's begin, as everybody's coming to their seats, with a land acknowledgement from the University of Waterloo. So on behalf of the University of Waterloo, I'd like to acknowledge that much of the work here takes place on the traditional territory of the Neutral, Anishinaabe, and Haudenosaunee peoples. The main campus, where we are today, is situated on the Haldimand Tract, the land granted to the Six Nations that includes 6 miles on each side of the Grand River. The University of Waterloo acknowledges that much of the water research occurs on lands across Canada and have rich Indigenous connections. And through this research, they work together with Indigenous communities to build lasting partnerships that respect, honor, and value Indigenous cultures, traditions, and wisdom. I think you may hear a little bit about that today. And just on a personal note, I'm really delighted to have been honored to study here about 20 years ago. Here on these lands. So this afternoon, we're celebrating the impact of Canada's $78 million Global Water Futures program. That's pretty remarkable. We'll reflect on some of the progress that the University of Waterloo has made toward advancing Canada's water security goals, as well as how the program helped elevate our reputation in water to new heights. You will hear directly from a handful of the researchers who have been involved in the program since it began in 2016. They will share stories about the work that they've done to tackle tough water challenges and the innovative solutions that they've developed with their teams. This is the kind of science that actively improves the daily lives of Canadians who are facing real threats such as drought, floods, and harmful algal blooms. We hope this session leaves you feeling hopeful and inspired to take on some of these challenges, and that the impact-driven research happening here at the University of Waterloo is something you can be part of. Together, we're ushering in a new era of resilience, innovation, and sustainable water management in Canada and beyond. So you have a chance to be part of that, if you're not already. Now I'd like to introduce you to one of the most recognizable faces of the Global Water Futures program here at the university, Professor Philippe Van Cappellen. Professor Van Cappellen is the Canada Research Excellence Chair Laureate in Ecohydrology and is one of Waterloo's representatives on the Global Water Futures Senior Management Committee. He's going to provide an overview of the program, highlighting the particular contributions made here at the University of Waterloo. Welcome, Philippe.
Thank you, Carrie. So good afternoon and happy World Water Day to all of you. And I would like to thank also the organizers for giving us the opportunity to reflect on the impact of the Global Water Futures program here at the University of Waterloo. So my task this afternoon is to provide a brief, high-level overview of the program before you hear more about specific research achievements from our panel here of Waterloo researchers. So the content of my presentation is based on a report that the University of Waterloo will release in this spring, but you can already have a preview of that if you take this QR code here, and that's a preliminary version of that website. So, the Global Water Futures Program started in 2016 with the aim to position Canada as a global leader in water science with a specific focus on cold and cold-temperate regions in Canada and around the world. So the stated intent of the program is not only to deliver leading-edge science, but also to work with partners, and non-academic partners in particular, to use this science to inform innovative solutions to existing and emerging water issues. And so these innovative solutions would then broadly fall in those 3 categories here. So first, to improve disaster warning and predictive capacity to forecast the risks and severity of extreme hydrological events and the associated impacts on water quality. So we're talking about storms, droughts, wildfires, algal blooms, etc. Second then, at longer timescales, to predict water futures through the use of big data and integrated models to assess changes in socio-ecological land and water systems. And then finally, to adapt to and manage risk by providing guidance to policy, management, and governance. And so with respect to this last adaptation and managing piece, one message that became increasingly clear as the research progressed was the need to include a wide diversity of perspectives, of voices and knowledge systems, including those of indigenous peoples and other underrepresented groups. The 4 core universities that were carrying that have been carrying the Global Water Futures program are listed down at the bottom of the slide. It's the University of Saskatchewan, Waterloo, McMaster, and Laurier. But in total, researchers from 23 universities across Canada actually have been participating in Global Water Futures research. So as I already said, the story of Global Water Futures started in 2016 when we were awarded $78 million of federal funding through the Canada First Research Excellence Fund. So project partners, including our respective universities, also chipped in another $180 million. And when you then account for the additional in-kind and cash supports from partners, this brings the total funding to over $350 million. So this makes it one of the largest, some will say the largest, university-led freshwater research program in the world. So of the 78 million in federal funding that was originally awarded to the program, about 20 million actually made its way to Waterloo researchers. This was enriched by the University of Waterloo with another $15 million. So if we don't count the additional contributions, partner contributions, cash and in-kind, that means that around or between $4 to $5 million per year have been invested in Global Water Futures related activities here at the University of Waterloo. So you're probably wondering what did we do with all that money? Well, I have this very nice sailing boat in the Bahamas. Oh, sorry, wrong script here. Of the federal money, of the federal funding, about $17 million went directly to research projects, and you'll hear more about those later. And then also it also served to support some core teams that were essentially providing services available to all water research across the campus. We also hired 5 new faculty members in strategic areas, and this allowed us to further strengthen the scope and the reach of water research and education here at Waterloo. And then we also invested about $2 million into new facilities and equipment. And just to give you an example, thanks in part to the availability of the Global Water Futures funding, we were actually able to respond immediately to the pandemic by, for instance, supporting wastewater testing for COVID-19. And that actually turned University of Waterloo into one of the key labs in Ontario carrying out pandemic surveillance through wastewater monitoring, and so contributing to monitoring the spread of the virus. So the University of Waterloo has led 12 Global Water Futures projects that together cover, as you can see here, a wide range of water issues, including, among others, looking at how to protect soil and water health in agriculture, improving water monitoring and managing big data, finding ways to better manage urban stormwater quality, assessing the impact of land-based best management practices on the water quality of Canada's lakes, highlighting the crucial importance of aquatic ecosystem services by performing economic analysis, understanding and mitigating threats to fish health and the implication for food security of remote communities, better characterizing the changing nature of our groundwater resources and how to protect them, and translating the research outcomes so they can help improve governance and decision making. Now, much of our work actually took place in the Great Lakes region, but also beyond that, and particularly also in Canada's north. And so you will hear more about these research projects in a moment from our panel. So the sheer scale and size of the Global Water Futures program at Waterloo becomes evident if you look at these numbers here. So this is what we've been able to deliver so far. And so some of these numbers, by the way, in particular, particularly the publications, that's a number that's still continuing to grow as we speak. So different from more traditional research programs, Global Water Futures has invested heavily in people and networks. And today is actually also a good example of that. So we're able to train over 300 HQPs, so mostly students, and this means 300 new people contributing to solving water security challenges, not only in Canada, but back home in their home countries as well. And as the numbers along the bottom here also illustrate, research, communication, and ultimate mobilization have also been a focus of the program. We've been organizing many outreach activities. We've been meeting with government partners and other private and public partners. We've been contributing to media releases to raise awareness about threats to Canada's water and some of the solutions to these issues. Another area where Waterloo has been at the front line is in managing research outputs. And for example, Jimmy Lin and his team have created a publication database for all the Global Water Futures publications across all the universities. And the database is sortable by year, project, university, author, and topic. But data management according to the FAIR principle, so the findable, accessible, interoperable, and reusable data, has also been supported by the Global Water Futures data management team. And so all the data that we have been generating in the program and will continue to generate are all or will become publicly available. And so including, for instance, through the Water Institute's Federated Research Data Repository page. In fact, the investments that we made specifically directing to core data management have really helped also the university to become a leader in open research data management. And that even before the tri-agency announced their new rules on open data. And so again, for that, if you want know more about that, I invite you to check out the online impact report. So altogether, we can look back at an impressive array of research outcomes with real impacts on the well-being, for the well-being of Canadians. But one aspect I would like to highlight here is the priority for us in the Global Water Futures program to understand water security challenges from multiple disciplines and multiple perspectives. We've done this by bringing also social scientists to understand human behavior together with natural science researchers, engineers, and economists. And so this has opened a whole new way of thinking about water solutions that are not only evidence-based, but also practically feasible and socially acceptable. And our hope is really that this will continue to resonate among all the students that were trained in the Global Water Futures program. So Global Water Futures is coming to an end this year, but a good piece of news is that funding was obtained to maintain the world-class observation and laboratories across Canada dedicated to water research and innovation. And this funding from the Canada Foundation for Innovation Major Science Initiatives program will provide continuity in the data flow that is needed to assess changes to our water systems, the associated risk, and how to manage them. And so at Waterloo, this means that we'll be able to continue to provide logistical support and analytical services for field-based research, for example, in the Grand River watershed, across the Great Lakes, or across a network of urban water observatories in southern Ontario. So a website describing the Waterloo-based Global Water Futures Observatory and how to access the services will be launched next week. And it will be part of a Canada-wide website that in turn will be launched in mid-April. So stay tuned. And with that, I'll turn it back over to Carrie.
Thanks very much, Philippe. It's a really helpful overview of the program, and now we get to hear some of the specific stories about the science and research that's been done under Global Water Futures directly from the people who did the work. You can find their full bios on the World Water Day website, but I'll give a quick introduction to each of them as they make their way to the stage. So first, Claude Duguay is University Research Chair in Cryosphere and Hydrosphere from Space and professor in the Department of Geography and Environmental Management. His work focuses on understanding of land, lake, and atmosphere interactions in cold regions through the development and use of new technology such as remote sensing and satellites. David Rudolph is a professor in groundwater in the Department of Earth and Environmental Sciences. He works with Professor Duguay on innovative ways to monitor water resources, but with a particular focus on groundwater in the north, which you'll get to hear more about in his presentation. Jimmy Lin is the David R. Cheriton Chair in Software Systems and professor in the School of Computer Science. His work is all about building tools that help users make sense of the large amounts of data. His team has created a number of the tools and resources that supported data management for Global Water Futures. This is a great group. Merrin Macrae is professor of hydrology and biogeochemistry in the Department of Geography and Environmental Management. Her work is largely in agricultural systems, studying the links between climate, soil, water, and biogeochemistry. Nandita Basu is Canada Research Chair in Global Water Sustainability and Ecohydrology, and a professor cross-appointed in the departments of Civil and Environmental Engineering and Earth and Environmental Sciences. She used data science and modeling and remote sensing to explore issues like nutrient pollution and wetland dynamics. Thanks to everyone for joining us. Round of applause. So things will go as such. Each panelist will have about 5 minutes to introduce their research and tell you a little bit more about some of their findings. And then we'll have a short panel discussion, and you have, if you have any specific questions for the panel or for one of the panelists, that would be the time. So we'll get started with a story from Claude, and I will just remind everyone that they have 5 minutes each, and when you're done, we can move right along to the next person and their amazing story. So Claude.
Do you have my slide deck? Okay, so the project I was leading is TTSW. We have probably the title there on the slide. Yeah, right. Why don't do that? Yeah, TTSW. You have the title up here. It's when we think about water security in our case, is how much water we have. Do we have too much? Do we have not enough? Drought and floods. Which is water quantity, and then there's, of course, the aspect of water quality, and these things are changing, of course, with climate change. So the overarching objective of this project was to develop and implement new technologies to improve the measurement and the modeling of the water quality and water quantity parameters. So in order to do that, we put together a team of, let's say, over 50 researchers from universities, from industry and government agencies to work towards that objective. More specifically, I will just go through, and I may be missing a few topics here. We were basically looking at the use of sensor technologies supported by AI. When I talk about AI, it's machine learning, deep learning algorithms, to derive and to measure and monitor water quality and quantity parameters. So one of the first instruments that was developed, which is not considered as being remote sensing because it's not a certain distance from the surface, but in touch with water, was developed by Carolyn Wren from Mechatronics Engineering, where you take a water sample, you can actually, with the instrument she developed, you can determine the lead concentration in water. That was one of the development that took place in our lab. We also had another colleague, Amagan from Mechatronics Engineering, with our group of students that developed a GNSS antenna. So if you think about the GPS satellite type in orbit, they send signals to the surface so that you can navigate. But it's been shown that this signal is also sensitive to surface conditions. So if you have changes in soil moisture, if you have ice on the oceans, or inundation, this type of technology can actually detect this. So our group developed this antenna that we were able to deploy on a tower near a lake to look at the sensitivity of the signal to ice thickness and ice conditions on lakes. Then we also used this technology, same technology, to put on board of a drone, and we flew the drone over campus, actually, near Columbia Lake, and we're able to look at the potential of that technology to map soil moisture. So that's from the field-based measurements. And then some of these sensors, other types of technology, we talk about hyperspectral remote sensing, which is basically solar radiation from visible to infrared wavelengths that are reflected by the Earth's surface. And this can be used to monitor, for example, water quality parameters, such as cyanobacteria, algae blooms, chlorophyll A in water columns. And this technology was deployed on board of drones, as well as aircraft, so we're moving up here in higher altitudes. And finally, other technology that was developed as radar remote sensing technology, where we're using radar to look at water quantity. And so water quantity is of course, you have water levels over lakes as an example, or you have snowpack. So basically determining how much water is stored in snowpack from radar remote sensing. So all these instruments were deployed in the field from airborne drones at different times during intensive field campaigns where people were collecting actual sample of soil moisture and snow also in the field to derive all these parameters. So this is kind of the array of projects we've been working on. Some of the sensors were developed on campus, like I said, in mechatronics engineering. Some were developed, an acoustic sensor also I didn't mention, by University of Saskatchewan. And other sensors such as the hyperspectral and the radar instrument we flew on board of aircrafts, and still continuing to do this, were developed by industry. Some actually industries in Canada, and at times where these instruments were being tested for the first time. Now, I'm not sure how much time I have left, but talking about the legacy of the project, we would say probably the biggest point here is informing the launch of future satellite missions. So right from the start, we engage in conversation with space agencies in Canada, in Europe, and also space industry about the ideas we had, the sensors we wanted to test, and the algorithms that we were developing using machine learning approaches. And so this has been informing future satellite missions. So there are 2 satellite missions that, under study at the Canadian Space Agency. One is called WaterSat, which would be potentially launched at the end of maybe in 10 years from now or so. That would be monitoring water quality parameters over oceans, coastal areas, and inland water bodies. So the research we've been doing on identifying the best band combination from hyperspectral data and the best algorithm to use are being already considered as part of these future satellite missions. Another one also with Canadian Space Agency is called the Terrestrial Snow Map mission. And this one is from the work we've been doing with this radar system on board an aircraft and flying over. We are showing the sensitivity of the instrument to snow water equivalent on land. And so this will directly be informing this future satellite mission from the Canadian Space Agency. And finally, there is another satellite mission where we had partners, and Dave can attest to this. We had Myriota from Australia, and now Australia is talking about launching a future satellite mission with an hyperspectral sensor. So Canadian Space Agency is in conversation right now with the Australian government, and where they would also add this 2-way communication instrument that Myriota was one of our partners in this project have been developing. Okay.
Okay, from here?
You can do it from there, or you can go to the podium, whatever you like.
Well, how about I try it from here since we've got our handheld? Okay, well, for the next 5 minutes, folks, I'm going to take you up to the far north in the Northwest Territories. And looking at this map, if you're sitting up here, you're already here. Everybody else, you have to get your toques and mitts, and we'll head up north. And while we're there, I want to talk to you a little bit about groundwater. So a question that might come to your mind, like why would anyone study groundwater, but particularly why would you study it in the north? Interestingly, groundwater is one of the fastest changing of our hydrologic components in the cycle, particularly in the north, and acts as a barometer for climate change and impacts of climate change. So a characteristic that's really unique in the northern terrain is the persistence of permafrost. So this perennial frozen ground that persists throughout a lot of the north. It's quite irregular in a sense that it's varied throughout, starting from the north to the south. For instance, if we're in Northwest Territories south of Yellowknife, it's quite sporadic, and it's very difficult to find it. If you move your way up towards the Beaufort Sea in Inuvik, it can be hundreds of meters thick, persistent. So this permafrost plays a big role in controlling how groundwater circulates, its quality, how it interacts with the surface. So it plays a really, really big role. So this part of Canada, as we always hear, seems to be warming at 2 to 3 times the rate of many parts of the Earth's surface. And what happens as a result of that, this excess heat is accelerating the degradation of the permafrost. So we're hearing about permafrost thaw at a rate that is much higher than we've ever seen in the past. So why does that make a difference? That's where our research really has come into it through Global Water Futures, and a particular observatory I want to talk to you about. So why is this important? So when permafrost thaws, it changes its volume in the subsurface. So as ground ice turns to water, the ground surface collapses. And this is not even over the entire ground surface because of the heterogeneity in the subsurface. So what happens is lakes that were sitting on top of the permafrost, many of them will drain as a result of the openings breaking and talus forming. Other places that are a little bit lower, lakes will form. So this whole surface water system is evolving, and relatively quickly. So we've been able to observe this occurring. What else is happening? So as this permafrost thaws, solutes that were entombed or entrapped in that ice start to become mobilized again. And sometimes they can be of danger to the ecosystems, the terrestrial and aquatic ecosystems. Methylmercury is one of them. One that you hear a lot about is the release of carbon. So a concern about how much carbon is stored in the permafrost as it's released may be a major contributor to greenhouse gas loadings. So changing in the permafrost world is different. Another one that we learned an awful lot about because of the ecologists working with us is the change in the groundwater surface position on the water table is causing reductions and changes in soil water profiles, which means wildfires are occurring in places that may not have occurred before, are persisting even over the winter. So people are tracking the wildfires that are still burning underground in many parts of the Northwest Territories. So these are really big issues as this evolution changes. So in order to study this, we were able to establish near the town of Norman Wells in the Northwest Territories, near the Mackenzie River in the central Mackenzie Valley, a research station where we could start studying this. And we developed this center in collaboration with the Dene Satu local community residents who have been partners in this project right from the start. They've helped us with co-design the research. They're on the site with us all the time. They support us when we're in the field. Incredible partnership. Their concerns are ones you might think of. Their typical traditional fishing areas are changing. They're concerned about the quality of the fish as a result of water changing in the near surface systems. They're worried about how, as the permafrost degrades, animals can't walk on the ground surface anymore. So the major herds that they actually hunt are taking different migratory routes than their traditional grounds. All really serious issues for them. And of course, as you can imagine, the persistence of wildfires and how incredibly difficult it is to predict that now is something that's got them extremely worried. They're isolated communities, and we were there this summer surrounded by wildfires, smoke, and so it's really a serious issue. So in working with them, we've been able to develop this site. So when the students and the researchers started to work at this observatory, the first thing they realized was how difficult it was to access the site, how remote it is, and how to get around it. So we leaned on folks like Claude and others to show us ways of using remote sensing. Satellite-based imagery has been really useful to help us track groundwater discharge points, for instance, using lower elevation airborne geophysical surveys, infrared camera surveys to find where groundwater is discharging, and integrating that with some portable, unique tools that you can use and walk around with in the field to measure on the terrestrial surface. All of that together has given us great insight. But I have to say, maybe the best insight we've had has been from our Satu local community residents who have lived on that land for hundreds to thousands of years and have seen these changes occurring. And they've taken us out to places where groundwater springs have started or gone away, where streams have dried up, where lakes have changed. So we were able to focus our research, and the students would go to those sites particularly to be able to do the work. So unbelievable how fortunate we were to have that traditional knowledge shared with us. And as we move now to transfer that observatory to one of the new Global Water Futures observatories, we're really hoping we can depend on our First Nations colleagues to stay with us for that traditional knowledge, because it's just unbelievably useful as we try to unravel this mystery underground. That's it for me. Thanks.
Okay, as they say, now for something completely different. So I'll start with an admission. I'm a computer scientist. I'm not a hydrologist. I can't even pretend to be one on TV. I started joining this project knowing absolutely nothing. I still know very little, enough to be dangerous, which is the worst possible state, right? So my area of research is natural language processing and information retrieval. These days, it's all about large language models, right? So this is under the general umbrella of AI, artificial intelligence. All right, so as they say, if all you got is a hammer, then everything looks like a nail. So I'm going to be sharing in the few minutes I have two things about AI and about data. All right, so the first is about AI. So I came into this GWF program with an AI hammer, and I was looking for nails to whack it on. And one of the things that I stumble upon is the stream flow prediction problem. Right, so this is work in conjunction with Julie May and Brian Tolson. I see Brian back there, applying neural network techniques to the stream flow prediction problem. And so there we applied a class of neural networks known as LSTMs to look at this problem. And how I came about it was relatively simple. Knowing nothing about the domain, I said, well, it's a time series problem. I kind of know how to do that. Here's a tool. Why don't we try it out? And so we took began by taking a completely data-driven approach, and guess what? It worked out pretty well. But we didn't stop there. With these, hammer and nail approaches, what we did with data-driven AI is you sort of throw out everything you know about the physical processes that underlie water, which was a good start for me at least. But later on, we wanted to build hybrid models that essentially combine the best of both worlds. So both the data-driven approach and an approach that relied on understanding processes that were going on. And so in the end, we got to something that was essentially the best of both worlds, which is a great outcome. The second thing I want to talk about, I'm losing my notes here, is the importance of data. Right? So quite simply, data is the thing that powers AI. And we as computer scientists know about this phrase, garbage in, garbage out. If your data ain't good, you're not going to get good results. Right? So this is work with Balika Prasad and Julie also as part of the data management sort of core activities. So there we focused on curating, slicing and dicing, and accessing data. So I'll give you very two simple description of the two things that we did. One is we looked at forcing, which are the inputs of all these models, and realized they come from really large data sets. And so we had to develop visualization and slicing and dicing techniques to curate them, to clean them before we can feed them into models. Once again, garbage in and garbage out. That's on the input end. On the output end, this has already been mentioned, we had a project that curated the output of the Global Water Futures publications, and so that was a huge effort in sort of encapsulating the intellectual output of the entire project in one easy-to-navigate site. And so I'll end with this thought, although AI is sexy and AI is cool, without the data, hard work that goes into data, none of that would be possible. And that's all I got.
I think it will just help. No. I think it's on. Is it on?
Hello?
Yes.
Okay, thank you. Okay, so I have some notes here. Okay, so just a little bit of context for why we did what we were doing with agricultural water futures. So as we know, water security, food security, and energy security are all linked. So agriculture is very much related to all of these things. Agriculture is something that is incredibly important to Canada. It's across Canada, and there's some key agricultural regions that we considered and we included in our work. And so one region was obviously the Great Lakes region, which is what we're in, and there was also the Canadian prairies. And so we assembled a team of about 11 researchers from the University of Waterloo, University of Saskatchewan, University of Windsor, and we also had researchers from Agriculture and Agri-Food Canada that were all part of our team, along with all of our researcher and trainees sorry, the picture just threw me off. Anyway, so yeah, we had a big team. So so climate change is something that threatens agricultural production and water quality. So from an agricultural production standpoint, it's not just about the crop production, it's about animal welfare. But then when we're thinking about water quality, there's some very large binational lakes in Canada. There's Lake Winnipeg, Lake Erie. Both are prone to water quality issues. I know Nandita will probably be talking about some of those, so I won't dwell on that. So anyway, so as I mentioned, climate change is something that is really threatening these issues with regards to our ability to produce the foods that we have been producing, is that going to become uncertain in terms of can things grow where they used to grow, or the same things grow where they used to grow, or can animals succeed where they have been previously succeeding? What about the intensification of the hydrological cycle and other aspects of climate change? What are the implications for water quality? These are all things that are uncertain under climate change. So when we start to think about ways to solve or address some of these issues, we have to remember it's not just a science problem, it's also a people problem, because it's about people, the people that are producing that food. What are the socioeconomic drivers that are, and cultural drivers that are motivating them to change, or making it so that they can't do the things that they might want to do? So these are all things that we have to consider. And so this is something that we put all together through agricultural water futures. So we included the prairies, we looked at the Great Lakes region, we looked at aspects of crops, we looked at aspects of water quality, and we looked at aspects of human and natural systems, coupled human and natural systems. So what did we find? Well, the fact is that there are regional differences in things like crop water use efficiency and moisture stress. We also found that there were differences in the drivers of water quality, things like flow paths, triggers, things like that. And also we found that there are differences in the efficacy of management practices, or best management practices, or BMPs. So meaning that what you might suggest to be effective in the Great Lakes region may actually be counterproductive in the prairies, and vice versa. And so in terms of the socioeconomic drivers, we also looked at things like the cost-benefit analysis of these BMPs, given that they work differently in different regions. We thought about things like incentives, water quality trading. And what's important about all of the work that we did is there was a lot of this being built into hydrological models, especially ones that were developed for cold regions, which is of course very important, because a lot of the things that we understand about agriculture and crops and water quality are not necessarily things that have been developed in cold regions. So the other thing that we did that was a really big part of agricultural water futures is we co-created knowledge with our stakeholders and our extension specialists and our government specialists all the way through. And this has been two-way co-creation of knowledge. We're also making sure that people are getting the information in the form that they need it, when they need it, and this has really enriched our experience. And so when I sort of think about the impact and the legacy, I really think that this is all helping us move towards improving our understanding of how climate change may be impacting some of the aspects of agriculture in Canada, and what kind of recommendations that we can make, especially as it relates to the targeting of beneficial or best management practices. And thank you very much.
Good afternoon. Happy World Water Day, everyone. Canada is a land of lakes. When we think about water, we think about rivers and lakes, and our lakes are under threat. Every year, we see increasing incidences of algal blooms, of beach closures. However, when we think about lakes, we often don't recognize that the land that drains into the lake, that flows into the lake, has a big role to play in how good that lake water is. Do you ever think about the fact that if you put more fertilizer on your lawn, that might impact more algal blooms in Lake Erie? We do not see that connection when it's far away. And that's the essence of lake futures. Thinking about the land that drains to the lake, the groundwater we pollute can feed into the lake. So it's not just a groundwater problem, it can be a lake problem. The essence of lake futures is thinking about the land with the lake, thinking about it together. So in this project, we brought together a really large team of lake people, with land people, social scientists, with economists, hydrologists, with biogeochemists and engineers to understand what can we do on the land that impacts the lake. And what is the role of the lake in those questions? From a practical policy standpoint, we were trying to think about questions that US and Canada are struggling with as a part of the Great Lakes Water Quality Agreement that says we need to reduce phosphorus by 40%. We were asking question, is this possible? Would that do anything? Now it's tough to boil down a 7-year grant with 21 PIs and many amazing scientists into 5 minutes. So I will try. From the watershed perspective, there were some key findings that came out. One of the key findings was the past matters, but it is our choice whether we let it haunt us or save us. What do I mean by that? Well, the fertilizers that we put on our landscape 10 years ago still pollute our waters. However, so the past does matter. However, those fertilizers are stored in our soils. There is those legacy phosphorus fertilizers are stored in our soils. We can apply less fertilizer and get similar crop production with better water. So it is our choice whether we let it haunt us or whether we let it protect us. Now, of course, it's not as simple as that, right? We have to figure out how much less, where less, what are the socioeconomic effects, how do we protect the farmers if they get a poorer crop yield with that less? That's where our focus should be, to understand the details of those questions. So that was one of the key takeaways. The second was with relation to livestock management. One of the key things that we found is that livestock manure has a key role in the phosphorus pollution that we are seeing. Now, we can think about that as a problem. We can also think about it as an opportunity. We have gotten really, really good in the last 30 years to treat human waste. Why can't we turn those brains around and focus a lot more on livestock waste? We also learned that we need to look beyond the obvious. While everybody is talking about phosphorus as the only thing that people should worry about in thinking about algal blooms, scientists in Lake Futures also figured out that no, it could be chloride that could change how the lakes mix, and that could increase blooms. So start looking beyond the obvious problems. And then the lake scientists came in and they talked about what is there in the lake that matters. There's legacy phosphorus in the sediment, so wait, to deal with that, shoreline erosion might be a way to handle that problem. And you need to think about the connection, just like you think about the connection of your lawn and Lake Erie. You need to think about how the lakes are connected to each other, how what's happening in Huron can impact Erie, or what's happening in Erie can impact. And then the economists came to the table and said, you need to design more cost-effective solutions. Targeting matters. We don't have money to waste. Resources are limited. So we need to design cost-effective, targeted solutions to address this problem. And finally, the time to act is now. We've been trying to deal with this problem of nutrient pollutions for the last 2 or 3 decades. And in the meantime, our climate is changing rapidly. We are getting warmer winters. Warmer winters, we are showing, brings more phosphorus pollution in through the groundwater. And that would increase our blooms. So we really need to think about addressing this problem now. And we need to look back to our past and say, well, we've done a ton of stuff. Do we need to keep doing more of the same? Or do we need to look at it critically and say, where do we do what solutions and how do we target effectively to design a better future? Learn from the past to design a better future.
Well, thanks to all of you for your introductions to your research. That's all incredibly fascinating work, and it's so neat to see how you've come from different backgrounds and different skill sets to find out some incredible things about water and how we can manage it going into the future. We have some questions now. If you've got questions, hold on to them for just a minute. We'll get started with one from me, and then maybe we'll go out and see if anybody has something specific they'd like to ask. Oh, and there are microphones here and here. So if you could speak into the microphone when you ask a question, that would be ideal. Thank you. So many of you spoke about the interdisciplinary nature of your work, and I think that is definitely the way forward. You've got to have different people from a diversity of backgrounds and skill sets contributing to this massive global issue that we're all facing. I'm wondering if through Global Water Futures, something specific jumped out at you in terms of partnerships, working across departments, bringing in different students with different skill sets to your team. What what about working on Global Water Futures help you expand your network into different disciplines and different partnerships? Who would like to take that on first? Philippe, yeah, sure.
Well, the first, can you hear me? Well, first of all, we kind of, because we were part of a Global Water Futures that is a trans-Canadian project. For instance, Merrin talked about, oh, well, we work here in southern Ontario. It's a big agricultural area, but of course this other important agricultural area is the prairies. Let's work together and maybe we'll find common solutions. But hey, one solution works here, the other one doesn't work. So you actually get a better feel of the diversity of the same problem. Can have diverse solutions or diverse manifestations across the different regional aspects. I think that is really being an eye-opener. The other thing is also, and was mentioned, that a lot of the water solutions were developed for more temperate climates. And so their application in colder situations are quite different. Groundwater is influenced by different drivers in the north than it is in the region here. So I think it's simply the exposure as an individual, but also as a collective research enterprise to a diversity of problems, and the fact that we have to look creatively at finding solutions that are location-specific, time-specific, that are specific for a given community, might work in one community, might not work in another community. What works in Toronto, downtown Toronto, is not going to work necessarily in suburban Waterloo region, etc. So I think it's more to see that water problems cross all these different aspects, geographical boundaries, cultural boundaries, you name it. And so I think that is basically, at least for me, been personally the big challenge and the big opportunity in Global Water Futures. And call it interdisciplinary, call it multicultural, intercultural, transdisciplinary. It doesn't really matter how you call it. It's basically to be open and open yourself to different perspectives, to accepting that somebody else is part of the solution. You're not just the only one that carry it.
Would anybody else like to take a crack at that one? Dave?
We take a short crack at it. So as Philippe was saying, this networking and this opportunity for us to meet and work with people from across Canada, I can guarantee you that in 7 years, my entire direction of research has changed because of the people I've met through Global Water Futures. So the people I've had no idea how the ecologists thought about groundwater. And they had no idea how I was looking at it. And we worked together on it, and it helped us to solve a problem. But equally importantly, my students are now taking courses at different universities. They're looking at problems in a completely different way than I can share with them. Their people on their committees have completely different backgrounds now. And I think that has enriched us at Waterloo in a way that we never would have had any other way. That exposure with people from across Canada, but also internationally now. It's clear that Canada's in the game to be an interdisciplinary worker in all aspects of water, and that's been great for us.
Let me hop in here. It starts off as absolutely sucking in the sense of multiple communities coming together and not even having the shared language. So for example, I imagine all these initial conversations with Julie about the thing that we're working on, and it wasn't until several hours in, I'm like, oh, that's what you mean. This thing you call calibration, yeah, that's training. And this thing called sensitivity analysis, yeah, that's like what we call hyperparameter tuning. So it starts off as absolutely sucking because you need to spend a lot of time establishing common vocabulary, but it ends up as absolutely rewarding to have everything come together, to adopt the different perspectives. And ultimately, that's what's necessary to achieve real impact. You know, all of us are to a greater or lesser extent denizens of the ivory tower, but ultimately the work that we do to have impact in the real world, it has to be through these interdisciplinary collaborations.
So persistence is key, is what you're saying.
Patience and maybe some level of masochism.
Can I say one thing? Thank you, Jimmy, for saying that. I remember saying this to the collaborative water program students. We entered into the interdisciplinary space, and we're always told this is this amazing space, and it is an amazing space. but it's also harder than a disciplinary space. It does suck. It does suck. At the start of it, it's harder. And you have to embrace that for something bigger, right? And I think if you don't acknowledge that, sometimes when we enter into it, we get frustrated easily because if we expect it to happen at the same pace, at the same rate as a disciplinary project, we will be frustrated. It will be slower. It will be more frustrating. It will be more iterative, and that's okay.
And even though it may take a long time, we do have something common to start with. We have water. We have water in common, and that's always a great place to start. At the end, I think toward the end, I'll ask you a question to that end. Let's go to the microphone. We have Andrew over at this one here.
Thank you, Carrie. My name is Andrew McCammon. I'm with the Ontario Headwaters Institute, whose mission is promoting watershed security in Ontario. I've been extremely impressed at this session today, and the work that the students have done requires a lexicon and a dictionary and a whole compass to figure out what these kids are doing today. It's fabulous. My question to you is one of frustration in terms of the value of taxpayers' dollars being spent on fundamentally important research that I admire and support. The question to you is, what do you see as the timeline for getting out of the box? Are your government agencies embracing your recommendations? Do you have mechanisms or thoughts about mobilizing people? Our water is in trouble, and I always say the wrong thing. This needs to get out of the ivory tower. What do you think about the prospects of getting all this information as an element of mobilizing society?
That's a really amazing question. Merrin?
Okay, I think that one thing that was common across a lot of our projects is that we were working with people outside of academia throughout, from the start all the way through these projects. And so there has been, like I had referred to, the co-creation of knowledge. This is what we were working with people in various branches of government. So as these things were coming out, as our study, so it wasn't just about sort of getting things, publishing them in our journals. Like, we've been working with people, and there's been a significant amount of outreach all the way through, which has really, I think, enriched our experiences across the board. I can't speak to when those agencies will act, but I do know that as an approach, this has been really, I think it's been really effective and really rewarding, and it's also very much impacted how we do things and we approach things. So I don't know if I answered your question, but.
I don't want to overstay my time. Agricultural community is rather different. I think the lakes, watersheds, and rivers issues are far more complicated, with interwoven non-woven silos of 4 different levels of government. So I'm just not gonna take any more time, just urge you to look at mobilizing, getting it out, getting your agencies to do stuff. Thank you.
Thanks, Andrew. Does anybody else want to make a comment on Andrew's question before we move on? Philippe?
I think this aspect of getting the public involved or transferring this knowledge from the ivory tower to the practitioner, it all depends a lot. Some information goes very quick. Some information will take more time or will not be directly applicable as such. So if the problem is relatively simple, I mean, the problem of chloride or salinization was mentioned briefly. Well, this morning on CBC, the local CBC, there was actually a program, this coalition against salt, or the salt coalition or something like that, because that's something that we see every day in the street, right? So it's something that directly connects, you can directly connect to that. And then, of course, if you then relate it to the aquatic life impacts, etc. So that is a fairly simple. I mean, we can find solutions for road salt. Dealing with algal blooms in lakes, for instance, as Nandita was mentioning, it's a very complex thing. It's what happens on land, it happens how the lakes react, the lakes are changing, there's climate change, etc. So that is a more complex. We don't have a simple solution, except that we all have to work together. In terms of the government agencies, I would say if you talk to a scientist in a government agency, they get it right away. But them convincing their management and then transferring that to real policy, and as you know, the different levels of policy in Canada are very complex to navigate. It's not a simple thing. But I do think that we need to think about also, it's not just the research that's important, it's also the educational part that's important. And I think that we are pushing people out of our ivory tower that hopefully will actually also have that message, or at least be able to convince their neighbors, the agency they're going to work with, the company they're going to work with. So I think there is probably more knowledge translation that is necessarily visible, but as I think it really depends also on the type of problem that you try to address. Is it a very complicated problem? Is it a simple problem? In environmental issues, I think in the past we had simple problems with fairly simple solutions. The problems nowadays are, unfortunately, a little bit more complex. The simple ones have been solved, basically. We know the solutions. So I think I would say that's part of it. But the watershed is a good concept because everybody lives downstream from somebody else. So we see that connection. We cannot live in isolation anymore.
Thank you. I think we have another question.
This is so high. Thank you for sharing with us. Dr. Basu and Dr. Macrae, you mentioned agriculture in your research, and we all know that agriculture is usually pointed out as the big villain in water problems, and the complexity of the issue with the food systems and international food regimen and cultural aspects of it and all that. So my question was about, when you look at the solutions for the agricultural problem and its connection to all the water problems we have, how radical are they? How are we talking about shifting societal paradigms on what we eat? You know, when we talk about how much animal protein we eat and how that is connected to the advancement of the agricultural frontier in countries like Brazil, etc. I think that's my question. Yeah.
Can take that. I think, thank you, Rodrigo, for that question. I think the solution is tiered and has to be tiered, right? So some parts of the tier, like diet change, is necessary, but it's the toughest to implement. But I think there needs to be education to implement, shifts in diet, not change in diets, but shifts in diets. And then there are other levels of solutions that sometimes I would argue, require us to think outside the box, which I don't think, this is my personal opinion, we do as much. So as an example, livestock manure is a source of greenhouse gases, source of nitrogen and phosphorus pollution. Livestock manure could also be used as a resource in digesters. Can we think about using this problem into a solution? Similar things, food waste. Food waste emits methane and takes up land. Can we think about them in terms of a solution, and what is it that is required to be done at the landscape scale to implement that? So I would think there's another tier of solutions that might be economically feasible, might also be practical, but require large-scale structural policy changes so that they can happen at a larger scale. And then there are another level of solutions which I think fall in the mode of behavioral change, which is livestock, which has to do with fertilizers and how they are applied, and those are longer term. So I always like to think about solutions as some things that could be done more immediately, whereas things that we need to, that have longer lag times in terms of societal lag times to be able to implement. We should be thinking about that portfolio. Honestly, Nick,
Anyone else want to take a crack at that one? No? Okay. We have another question. Do you want to go up to the microphone, please?
Hi, thank you so much for sharing about your work. When working with communities and government partners, I was wondering if you found any specific types of questions or research projects that really got them most excited. What did you have the best reception from those partners from?
Can I also add private sector partners to include a few more of our panelists to that question? That's a great question.
That's a really great question. And one of the things that I've seen is if there's an issue that's causing immediate problems in the community or society or impacting people, they tend to get the most attention. So the whole issues last year with wildfire, there's been so much research trying to get to the bottom of what's causing this and how to get to it. So it always seems to be the case there has to be sort of a disaster or an immediate need, and that's when the government and the let's say the managing groups are so concerned and they want to get engaged. So for us to be nimble enough to get out of our ivory towers and participate in whenever we're asked to do it, that's our challenge. We have to be able to do it. I would find that as being the most active areas that they want us to work in.
Go ahead, Merrin. Did you want to say something?
Well, okay, I was just speaking about sort of some of the things that have gained the most traction, I think, in some of them is where we've been able to provide toolkits and ways to move forward. So the example I'll use is from our specific example, and that is, again, back to the targeting. Oftentimes, when we think about policy and recommendations, we might say, okay, this works this way, and roll out some of these programs so that people would take up some of these management practices. But the fact that we've been able to move towards more prescriptive things to say, this is going to work well here, and this is not going to work well, versus over here, this might work, and what you did over here wouldn't work. The fact that we can actually make it more prescriptive and move forward, I think, is something that has really gotten a lot of traction, because we've been able to, again, build toolkits and really solid recommendations that we've been able to work with our partners in. And that's just my agricultural example, but I know there have been others.
Yeah, from the private sector side of things, I've been working in new technologies, new sensors being developed. Some of them were just very recently developed by the private sector. And I was talking about hyperspectral remote sensing. It's been shown quite clearly that that type of instrument is very useful for agricultural purposes, growing vegetation on line and so on. Now they wanted to test that over water. And there's some issues of using some of these instruments over water. There's an aspect, which I'm getting to the details here, what's called signal to noise ratio. And over water, it shows basically it's not working well with some of the sensors that were originally developed. So with the work we've done with these flying our own instruments on board of drones and aircrafts, we've been able to identify that, well, for water purposes, you need a certain, precision of your instruments, before this could go on board of satellite missions. And, I was mentioning about the impact that we've had on the legacy on future satellite mission, and that's one of the, not only from I was mentioning the Kane Space Agency as one of the partners in here and planning on launching future satellite missions, but private sector is moving much quicker than the regular space agencies. They're launching constellations of satellites. And so in that respect, some technology I was mentioning, GNSS, there is a company that has been launching quite a few of these GNSS types of satellites. And we've been collaborating with the private sector in that respect. They're interested, they're looking for applications. They say, okay, we've got this technology now in orbit. What can we do with it? And though a lot of the work we've done through the TSW project is to demonstrate that this can be done. Some parameters can be derived. And so that encourages them, of course, to launch these future satellite missions. In both, like I said, the government agencies, but also the private sector.
Thanks, Claude. We have another question over here.
Yes, please. Thank you. My question is for Dr. Cappellen, but other insights will also be welcome. So despite this interdisciplinary approach, the collaboration between different institutions and universities sound great. So despite the funding, what do you think is the factor that drives this collaboration between different institutions and really work together under one golden umbrella? My second kind of question is, do you have any efforts or plans in terms of collaborating with institutions and academic universities with the Global South, because it's not just Canada's issue, right? Thank you.
That is a great question. Set of questions.
First of all, the funding is extremely important. And this is something that maybe we should have emphasized at the very beginning is the Global Water Futures gave us a time window of 6 years. Now, because of the pandemic, we got extensions, and we're now actually in year number 8. So if you have that time horizon where you say, well, we have some steady income and we can use it to get more matching funding and get also exploratory research that is not necessarily that easy if you're dealing with much shorter grants. That is actually a big factor, and that's something that also I think is something that is slowly permeating also the funding agency, that hey, just like little 3-year grants after little 3-year, you basically are forcing people, like at research institutes or at universities, to basically focus on what is feasible within 3 years. So you don't have that long horizon, so you can't invest too much time in like, well, it would be cute to go and collaborate with this person and try this out, and maybe it's not going to work. So I think the funding is important. The other thing which was very motivating, I think, in specific to this project, was that it was, hey, you're going to have to work with partners, and these partners are not going to be the colleague that works next door of you. These are going to be government agencies, these are going to be stakeholders like farmer communities, etc. So you're going to have to invest time into that, but the reward is, of course, that you can collectively work together to maybe finding a solution, or at least better delineating what the problem is, or what the impact could be, both upstream and downstream of where you are. So I think to me, that is really important, is to be able to provide that rewarding element. And again, these collaborations are based on trust, right? And trust is not something that happens overnight. That is something that you have to deserve trust, so you have to invest it. It's also what you see when you suddenly show up in a remote community. I mean, you're just a guy that just shows up. I mean, are you going to be there for a while, or are you just going to basically go in and out and get my samples, and we write up a paper? So I think it's a mind shift that you need to have. And I think that is, I always believe in diversity. It's not that there are not some really fundamental research questions that need somebody to sit at their desk or spend 48 hours in the lab just to figure that out. And that is perfectly fine, and universities certainly have that mission still to advance the state of the science. On the other hand, we're also much more aware that essentially it's no longer the science for the science necessarily, it's also what can you do with it, is it for the greater good, and that often requires collaborating across disciplinary areas. And again, it's not just the research, it's also the training that comes with it. Your personal training, but also the training that you can give to the next generation. And I frankly forgot your second question. Oh yes, so I think that's essential. That has, of course, there's cold regions everywhere. I mean, cold regions also include high altitude areas. So there is collaboration through global water futures, but I think as scientists, we're always looking to collaborate further with the global south, with more upcoming economies, etc. So there's a lot of research partnerships with Southeast Asia, with South Africa, with Rwanda, for instance. So there is definitely that, and I think one of the things that our universities can do is offer also training possibilities to students from the global south, where they might not have all the facilities that we have here, but then essentially to also make those facilities available. And I think the observatories are one ideas where maybe this is a model that we can also translate in other areas. I was recently asked by a ministry in Rwanda to come and set up an observatory in Rwanda to look at Lake Kivu, for instance. And basically they say, well, we want to learn from you, but I know that if I go there, I'm going to learn more from them than they might learn from me.
I think we have another question.
Yeah, I do. I'm curious, how do you navigate tensions and conflicts that arise among researchers and communities with differing value systems in interdisciplinary work?
Awesome question. Did everybody hear that? How do you navigate tensions that arise with partnerships or communities that have different cultural values or different outlooks on the work that needs to be done? How do you navigate that?
As best as possible. I think acceptance and respect are the basic elements. To accept that there are different ways of thinking, different ways of knowledge, different perspectives, different interests, and that is something that you have to go with an open mind and try to do your best. And it might work, might not work, but at least you try. I don't think there's a universal recipe for this.
I think when you try to do something hard, and interdisciplinary work, this kind of work is hard, there is going to be conflict. So kind of acceptance of that conflict. I had one time a colleague, I was having a conflict with something related to interdisciplinarity, and my colleague said, don't you wish you didn't do this so you didn't have to deal with this? And I thought about it and I said, no, I hate conflict. I avoid conflict as much as I can. But sometimes for doing this kind of work, you have to accept conflict. I've read a lot of conflict resolution books. There's a set of books called Crucial Confrontations and Crucial Conversations that I've read. So, and you get better at it over time. But acceptance and respect, as I think, are the key things.
Do you want to talk, Merrin? Yeah.
Just like to, thanks. I agree with what's been said, and I guess I think the other is willingness to listen. So it's accepting conflict, but it's hearing people's perspectives and trying to understand where they're coming from to try to resolve some of these. So I would just add that.
Just on that, it's amazing when people look at these problems and start to take them apart, how it turns out that everybody's real goal is pretty close. So once they talk about it and get the communication out there, they realize we're really on the same game here. We're just seeing it differently. So let me tell you how I see it, and I'm going to listen to how you see it, and we really want to get the same goal here, so let's work together. And I would say that's improving. For whatever reason, there's an evolution towards, I think as Philippe said, open-mindedness, and you learn so much if you can keep an open mind. No two ways about it.
That's great, thank you. I think I did hint at a surprise bonus question, and we're nearing the end of our time here. I'm sure our distinguished guests will stick around for any follow-up questions or discussion, but in the interest of finding common ground on World Water Day, because if not now, when, could you tell us what is your favorite body of water and why? I have used this question countless times in my career, and it always brings people together, always. So I will put Nandita on the spot, and we'll come down the line.
I don't play favorites. And that is the essence of it. I mean, truly, I am not a place-based scientist. I like looking at global challenges and global problems across scales. One of my favorite wetlands is the wetlands in the city that I grew up in, and where I learned about the multifunctionality of wetlands. This was a wetland, I grew up in Kolkata. This was a wetland that was at the kind of downstream end of the city and was a body of water that protected against floods, removed nutrients, and there was a lot of people that had aquaculture there. So it was just like this multifunctional system. So, and now it's a Ramsar site. A lot of it is lost from urbanization. So, is it my favorite? No, but I grew up there and it's my first. I enjoy thinking about large scales and things across scales.
I like your pivot, and a wetland absolutely counts because they are so cool. Merrin.
So I also don't play favorites, but I have to give an answer.
Nobody wants to commit.
Okay, so I'm going to go with Lake Erie because it's a fighter, right? It was undergoing change and threats, and then it recovered, and then it's been undergoing threats again, and it's fighting, and we just got to go with the fighter.
And the computer science friend.
What a weird question to ask a computer scientist. So yeah, I mean, yeah.
Dive in.
So I would probably say the Charles River Basin in Cambridge, Massachusetts, because I grew up there. I got my all my schooling is in the Boston area, and that is just such a focus of the Boston area in terms of entertainment, in terms of leisure, in terms of commerce, and so my heart still goes out there.
My turn? I think I know the answer to this already. Is anyone from Manitoba? Some Winnipeggers? So you know where Whiteshell Provincial Park is? So my favorite body of water, hands down, is Big Whiteshell Lake in the Whiteshell Provincial Park. Grew up there from a 2-year-old to a 16-year-old. Got an appreciation for the lakes of the Canadian Shield there, and have have that for the rest of my life. If I have a vacation opportunity, I go to the Canadian Shield and be around the lakes. And I also learned to barefoot water ski on that lake, so that's always my favorite.
Barefoot.
Out of the side of the boat, to be truthful.
I love them all. From space, I look at them from space, and I see all of those from high resolution, low resolution satellite data. But more seriously, I would say probably again it brings you to being younger and good memories. Actually, in my case, it's just south of Montreal. There's a river, the Richelieu River, that flows into Bassin Chambly, and
applause for the
actually,
water body.
that's how I got interested in my main topic of research, which is lake and river ice dynamics, and where you have the Hydro-Québec as a little dam, and then there's water flowing, and then at minus 30 degrees, there's starts to have little patches of ice flowing, and then it flows into the Bassin Chambly. Once you get to springtime, there's ice jams, and you see trees have scars on the side because of the ice jams. So that's my lake. And of course, I used to skate, play hockey a lot. So the Bassin Chambly was a place where I would skate as well.
Difficult question. In fact, my favorite water bodies are unfortunately not freshwater bodies.
That's okay too.
They're more saline.
Nandita chose a wetland.
That's true. Well, no, but I used to work in Georgia along the coast, and so you have these salt marshes, and in particular there's an island called Sapelo Island. There's a very small community that lives there. So maybe I think it was about 50 people. They're descendants of slaves that used to work on the plantation on the island, and then the plantation was basically after the Civil War was taken away. The people stayed there. And University of Georgia actually has established a field station there called Sapelo Island Field Station. And for any ecologist here, you might remember the name of Odom. Odom is one of the great ecological minds, active in the 50s and the 60s, and actually he was part of the establishment of that. And so you have these incredibly pristine white beaches, huge amounts of spartina, and then this interface where land and water and land and water and land and water kind of move into each other. It's a fairly high tidal activity, so it's absolutely very dynamic. There's one little problem, it's full of alligators. The rest.
Well, thank you for that. I'll add that mine is probably Lake Ontario, looking out from the water treatment plant. Because it's a great view and it's just such a special place. It's R.C. Harris Water Treatment Plant, if anybody's ever been there. Great view. And on clear days, you can see across, and it's a nice place to bring my daughter. So I would encourage any of you that if you felt a connection with anybody speaking today about their research or their body of water or their wetland or their not fresh water, please feel free to talk to them. Props are people too. And maybe we'll encourage some conversations that lead to a beautiful partnership, doing some research together at some point. Thank you very much to our wonderful panel. Loved hearing about your research, loved hearing about your water bodies, and appreciate all of you being here as well. Thank you. So to wrap things up, I'd just like to invite Kevin Beamer, who is the Managing Director of the Water Institute, to the stage. There you are, Kevin. And I think we're all able to leave the stage.
Oh,
okay.
Stay there for a sec, please. Yeah, it's my pleasure to provide some closing remarks and thank yous today on behalf of the Water Institute. So first of all, I wanted to thank you, Carrie, to bring your excellent professional facilitation skills all the way up from Toronto was much appreciated, and you're welcome back at Waterloo at any time. But thanks very much for your work today. And the panelists, I think I loved the format because it gave us just a brief snapshot of how Global Water Futures has really elevated the water research enterprise at Waterloo over the past number of years. Like, we're talking almost 50 professors at Waterloo participated in this program, so that's like 1/3 of the water professors, over 300 students and postdocs, so it's just been a huge undertaking over the past couple of years, but a lot of it led through these 6 professors on stage. I'm super thankful, and I'm also excited that we're able to announce recently that the Global Water Futures Observatories will keep the, I guess, physical network and hopefully the human network alive for a few more years. So thanks again very much for that. I just wanted to point out that, you know, I'd be remiss if I didn't, after this morning's session, also remind us that there's a lot of work yet to do in Canada, and in particular with our Indigenous partners. But there's also so much good going on that we should take home with us. So thanks very much. I'd like to, on behalf of the Water Institute, present all of you with a small gift of appreciation as you leave the stage. Thank you.
I said, that's interesting.
Thanks, you did great.
Okay, today was a lot about youth, and I would like to acknowledge the great poster session that we had at lunchtime that showcased the awesome work that's going on from our students, or a subsection of our students from across the university. And they were all great, but I'm going to ask Autumn to come back to the stage to announce today's winners.
So firstly, congratulations to everyone who presented their research and poster. And thank you to the judges who also assessed them. So I'm going to announce the winners. So the first award is the People's Choice Prize. And what's special about this one is that everyone in the audience today had a chance to vote for their favorite poster. So the winner is Sarah Kowalchuk. The next one is the Best Upcoming Research Prize, and this category specifically acknowledges outstanding work from an undergraduate student. And the winner is Jordan Lee. So now for the graduate students. I heard that this was a very close call but the winner of the Best Runner-Up Prize is Laura Anderson. And finally, we have the prize for the best poster of the 2024 World Water Day competition, and that's Risa Islam.
Okay, while we're doing this photo shoot, I just wanted to thank Autumn once again for being here with us this morning and reminding us about the importance of listening to and respecting those who have gotten before us and help shape our future, and the power that our youth, our students and youth have in helping us get to where we want to be. So many thanks, Autumn, for making the trip. And I'd also like to give a shout out to Jeff Burnett at Seeing Red Media, who works with Autumn, and invite you to Seeing Red Media is a cool company based at Six Nations that amplifies the voice of of Indigenous people, and they've got the best website that I've seen in a long, long time. So I'd invite you to visit Seeing Red Media. Okay, I would like to thank, I don't see anybody, but I'd like to thank the Fed Hall staff and U of W Catering for helping us with all the refreshments and food today. Big thank you to Eric and his AV team. That was seamless, Eric. AV is always best when we don't notice them, so we didn't notice them today, so that was great. Thanks very much. The students, the Society of Water Institute graduate students are awesome. They're dynamic, and they do so much great work around the university, including a lot behind this, well, in front of the scenes and behind the scenes to make today happen. They were wearing t-shirts, a lot of them today, volunteered all day, so I'd like to thank the students of the Water Institute. And in particular, Arisha, Imran, and Julie DePaul, who are right around somewhere at the wave. They were part of the planning committee, right? So they've been working on this since October and have really done yeoman's work in putting this together on behalf of their larger student team. So many thanks, Imran and Julie. I would like to thank Melissa Ireland in our Indigenous Affairs office and her colleagues for supporting us this morning and contributing in a very meaningful way, in particular to this morning's session. I would like to thank Engineering Outreach. For those that weren't here this morning, you might not know this, but we bussed in 60 students from Six Nations Polytech and Pauline Johnson Collegiate in Brantford for this morning's session with Autumn, and that was made possible through the support of the Engineering Outreach Office. So many thanks to Jared Stryker and that whole team. And then finally, I would really like to give a heartfelt thanks to Savannah Sloat from Science and Scarlett Van Berkel, who's a student in School of Environment, Resources, and Sustainability, right, sirs? Yeah. Who co-facilitated this morning's circle talk. Again, many of you were here, but some of you weren't. I found it really, this word's used lightly, but inspiring. They helped create, I think, a really comfortable space for everybody to speak with respect and positivity and constructiveness. And one of them was sitting on both sides of Autumn, and I think the three of you should go on the road. You made a really great team. So again, thanks to Savannah and Scarlett. We have a small gift also for you. Okay, and finally, my Water Institute colleagues, Nancy Gauthier, who did a lot, but she basically put together the afternoon panel session, okay? But she conceptualized it and organized it and executed it. So well done, Nancy. Thanks so much for your help today. And then finally, Julie. What do we say about Julie Grant? So Julie did 90% of the, sorry, Julie, both Julies and Arisha did most of the work today. But Julie from the Water, my colleague at the Water Institute, yeah, I don't know where to start, but Julie basically did all the promotions, logistics, and so much behind in front of the scenes. So I'd like to recognize Julie's efforts today. Okay, finally, thank you all for participating today, for taking the time to join us. Hope you have a great rest of the afternoon. Safe travel home. There's a SWIGS event tonight downtown Kitchener. Have fun there for those that are going. Thanks again. Have a great day, and we'll see you next World Water Day.